Okay, good morning. This is Professor David J. DelosReyes again. Okay, uh, the time is 2:36 a.m. This is August 21 already. Okay, my next topic for this morning will be long video format discussion of college algebra, and we will now be finishing the topics on quadratic equation. This will be the last topic on quadratic equation. Okay, because we have done already these 5 solutions of a quadratic equation. We have done the application problems that involves quadratic equation. And the last topic under quadratic equation will be the graph of a quadratic equation. Actually, I will just give you a summary on the graph of a quadratic equation, because the graph topic is actually a different topic, that is actually analytic geometry. So I will just give you a preview of what is analytic geometry means. Okay, let's proceed. Okay, our last topic under quadratic equation is how to graph the equation of a quadratic equation. How to graph. In brief summary, the graph of a quadratic equation is actually a parabola. Parabola, it could be an opening downward or opening upward. They have the San Francisco Bridge. It seems like an example of a parabola, but it's not a perfect parabola, because the cable of the San Francisco Bridge is a little bit, it is like that. It's not like that. But they say that it was designed actually based on the study of parabola. Okay, let's proceed. The equation of a quadratic equation is actually given by y equal to ex squared plus bx plus c. If the variable on the left hand side is y and the variable on the right hand side is x, that is the so-called Cartesian coordinate system, meaning if we try to graph this one, the horizontal one is actually the x-axis and the vertical one is actually the y-axis. And this is the so-called Cartesian coordinate system. The abscissa is x, the ordinate is y. This is now analytic geometry. That's why I told you a while ago. This topic, excuse me, I will do something. Okay, I'm done. Okay. The equation of y equal, let's continue. Y equal to ex squared plus bx plus c. It's a parabola. Okay. The variable on the left is y, the variable on the right is x. So for x, it should be plotted along the horizontal, and for y, it should be plotted along the y. This is termed to as ordinate, and this is termed to as abscissa. Okay, let's try to bring out the so-called standard forms. So I am telling you, the equation of this, if we try to graph it, there are 2 variations. The one that opens upward, this is a parabola that opens upward. And this is a parabola that opens downward. So the one that opens upward, it seems it's the variation of the so-called San Francisco Bridge. It is something like if we got a force over here and we got a force over here, It's just like the pose of a transmission line. If we try to erect the transmission line, it will be in the variation something like that. Okay? And this graph here is referred to as a parabola. So in real life, there is actually an importance of a parabola. So at least we know how to graph a parabola. Okay, let's try to graph a parabola. The standard form of a parabola will be of the form y equal to a times the quantity x minus h quantity square plus k. Okay? The additional variables on the right hand side are actually h and k. Okay? There is an additional a over here and there is an additional k over here. And what's the meaning of h and k? H and k is refers to the coordinate of the vertex, this one. Right? The lowest point of the first graph is termed to as the vertex, capital letter B. And the coordinates at that one is actually given by h and k. For the other graph, if the parabola is downward, okay, if the parabola is downward, this is the vertex. And the coordinates of the vertex is given by the value h and k. So under the formula standard form, the value of h and k refers to the coordinates of the vertex. Okay? Vertex is the lowest point on the parabola, or the vertex will be the highest point on the parabola. Okay? That's the equation. That is y equal to a times the quantity x minus h quantity square plus k. I place it here. The vertex location is at the coordinates hk, meaning the abscissa is h and the ordinate is k. And I will just mention the axis of symmetry. Axis of symmetry is the vertical line passing through the vertex. Axis of symmetry is this one. Okay? And for the first one, it is this. It is just the vertical line that passes through the vertex. Okay? That is termed to as axis of symmetry. Okay? What are the important points on the parabola? The important points on the parabola is the so-called minimum point and maximum point. Okay? This one is minimum point because the parabola opens upward. So the lowest point on the parabola is the vertex, and we call it minimum point because at this location, okay, this is now differential calculus, because at this location, dy dx is equal to 0, or dy dx is termed to as slope. It is a slope, right? Dy dx is termed to as slope. The slope of any point on any given curve is actually the angle in which a horizontal line makes with the point. If we pass a horizontal line at the minimum point, okay, for it to be minimum and maximum, okay, the slope should be 0. 0, meaning the angle of inclination, it has no angle of inclination. For it to be a minimum and maximum point, the slope at the minimum point and maximum point should be 0. Okay? That is, m should be equal to 0. Okay? As you can see it, we try to draw a horizontal line at the vertex. We term to this one as minimum point, and also for the maximum point, if we draw a horizontal line passing through the vertex, we could call this one as maximum point. Because at this point here, okay, the angle of inclination of the tangent line is actually equal to 0. It is 0. Okay? For it to be a maximum point, okay, This is the, what you call this, the markings of the maximum point. If from the given quadratic equation a is greater than 0 or less than 0, okay, it should be a parabola that opens downward. It should be this one. So for this figure number 2, a here is less than 0. It opens downward. Okay? And for it to become a minimum point, okay, a should be greater than 0, and that parabola should opens upward. Okay? Minimum point, upward. This one. If the parabola opens upward, okay, the vertex is termed to as the minimum point. It opens upward. And the condition for that one is a is greater than 0. For the first one, maximum point, a is less than 0. Okay. What are the other important things on the maximum and minimum point? The other important things under the maximum and minimum point is the value of h, the value of h, and the value of k. What is h and k? H and k are the coordinates of the maximum and minimum point. So if we are given a quadratic equation of the form y equal to ex squared plus bx plus c, to compute for the value of h and k at the maximum point and the value of h and k at the minimum point, these are the needed formulas. Okay? I'll place it here. H will be the ratio negative b over 2a. And the value k will be c minus b squared over 4a. The value of a and b emanates from the equation y equal to ex squared plus bx plus c. So this b and a comes from here, right? And the value c is this one. So memorize this by heart. For a parabola to compute for the value of the abscissa of the maximum and minimum point, this will be the formula. That is negative b over 2a. And for the value k, it will be c minus the ratio b squared over 4a. This will be the abscissa, and this will be the ordinate of the maximum point and minimum point. Okay, let's try to bring out this formula here. Because it was given in our textbook, and they just placed that the value of h will be negative b over 2a. And I was thinking that they didn't give us a solution on how to bring out this one, so I did it myself. The solution is actually by the study of differential calculus. Okay. The derivation of this, I will give you, but the subject matter will now be differential calculus. So we switch a little bit to differential calculus because our textbook just give this one without giving any derivation. So I derive it myself by using differential calculus. It's something like this. It's easy. We are given the quadratic equation. Am I still on the camera? Y equal to ex squared plus bx plus c, okay? We will take the first derivative of the left and right, okay? The derivative of y with respect to x will be dy dx. The right hand side, the derivative of ax squared, it will be 2a times x plus b, this is actually times 1. Because we are taking the derivative with respect to x. The derivative will be constant with respect to x, this is 0. Or this is gone. We remove the 1. So meaning to say, if we try to take the derivative of left and right, dy dx is actually 2ex plus b. Okay, that's differential calculus. If you are still in algebra, okay, just watch this one and then take note of it. So when you go to differential calculus, you could go back. But the manner in which these two equations was derived was actually from differential calculus. So after taking the derivative, dy dx equal to 2ax plus b. Okay? And under the study of differential calculus, the value dy dx is termed to as a slope. Okay? And for a maximum point and minimum point, the slope here, the slope of the line here is, the slope is m is equal to 0. And for this one here, the slope is also equal to 0. So I place it here, dy dx is equal to slope. That is by definition under the study of differential calculus. And for it to be maximum, or it could be a minimum, the value should be equal to 0. So what we will do, we will equate dy dx equal to 0. We place it here. So 2a, okay, multiplied by, we set the value of x equal to h. Why h? Because at the location maximum point or minimum point, the value of the abscissa here is actually x is equal to h. And the value of the ordinate here is y is equal to k. Right? So this key here is actually this one, and this h here is actually the, right? So at the maximum and minimum point, okay, x will be h, so we will place x equal to h from the first derivative. 0 will be equal to 2a times h plus b, and solving for h, negative 2h will be equal to b, or h will be equal to negative b over 2a. Okay? This equation here is actually this one. That's the derivation. It was not derived from algebra. It was derived from integral calculus. Right? And for the value k, okay, we'll go back to the given equation. Y equal to ax squared plus bx plus c, right? Replace y by the value k, and this x here, replace it by negative b over 2a. Okay? Replace this one by negative b over 2a. Of course, you square this one because this is squared. Okay? So, by referring to this equation here, it's here. K will be equal to a times the value x. But at the maximum and minimum point, the value of x is equal to h, and that is actually negative b over 2a, quantity squared, plus b, multiplied by x, which is negative b over 2a, plus quantity, plus c. Am I still on camera? So simplifying this one, this will be ab squared over 4a squared, or simply 4a times a, because negative b squared is b squared times a, and 4a squared is actually 4a squared, or simply 4a times a. This one, b times negative b will be negative b squared over 2a, this plus c. Then combining similar terms, this is this a here cancel with this. So actually, this first term and second term are actually similar, but we could not combine them because the denominator on the first one is 4a and this is 2a. So we must have to multiply this by 2, and this is by 2. So 2a times 2, that will now be 4a. Okay? So it will now be b squared. This will now be negative 2b squared. So it will now become, what will come out? K, okay, equal to, we subtract this one, it will be negative b squared over 4a plus c, or k now will be equal to c minus b squared over 4a. So this one here is actually this, and it was this. Okay? So the derivation of the coordinates of the maximum and minimum point for a parabola, it was actually derived from differential calculus. So memorize this by heart. The abscissa of the maximum and minimum point is given by the equation negative b over 2a, And for the ordinate of the maximum and minimum point, it will be c minus b squared over 4a. Okay, that's it, guys. Okay, that is only the important things under the graphing of the equation of a parabola. Okay, at least we now know what is the maximum point. We now know what is the minimum point. At least we now know how to compute the abscissa and ordinate of the maximum and minimum point by using this formula C. Okay, that's it, guys. So for those of you who are taking up college algebra, this is for you guys, okay? If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Okay. This part of the, what is called this lecture is actually part analytic geometry and differential calculus. Because in bringing out these two formulas, it was not derived from algebra, it was derived from differential calculus. So I bring you this out, just take note of this. So when you go to differential calculus, you could go back. I presented this one just to show you that this equation was derived from differential calculus. Okay, good morning from Los Angeles. This is Professor David J. DelosReyes.